Okay, just for a second, I want you to imagine an object. An object so mind-bendingly heavy that it just breaks the very rules of the universe. A place where concepts like up and down completely lose their meaning, and where time itself starts to crawl to a stop. All right, let's dive into one of the cosmos's greatest mysteries.
First things first, let's get the biggest misconception out of the way right off the bat. Despite the name, a black hole is not an empty space. It's not a hole at all. In fact, it's pretty much the exact opposite.
So, if it's not a hole, what on Earth, or what in the universe is it? Well, to get that answer, we've got to look at what happens when something gets unimaginably, almost impossibly dense.
Let's start with the basics. Just try to forget the name for a minute, and let's focus on what a black hole actually is.
A black hole is, and this might sound weird, arguably the most solid thing in the entire universe. It's an object with a gravitational pull so intense, so powerful, that it crushes a tremendous amount of matter into a tiny, unbelievably dense point.
So where do these cosmic monsters even come from? Well, their birth is one of the most violent, most spectacular events you can possibly imagine.
The simplest way to think about it is this. Most black holes are basically the magnificent corpses of dead stars. They're the final, dramatic chapter in the life of a very, very big star.
Here's how it all goes down. It starts with a massive star, okay? We're talking at least 10 times bigger than our sun. When it finally runs out of fuel, that outward push from its nuclear furnace just stops. And at that moment, gravity wins. The star collapses inward on itself, triggering a cataclysmic explosion we call a supernova. But for the biggest of the big stars, the core doesn't stop collapsing. It just keeps crushing itself smaller and denser until all that mass is squeezed into a point so small it has effectively zero volume. And right there, a black hole is born.
All right, now let's take a little tour of one. To really get how a black hole works, you need to know its key landmarks.
There are really three main parts we need to talk about. You've got the accretion disk on the outside, the event horizon in the middle, and then the singularity, right at the very heart of it all.
So the part you actually see in all those amazing images, that's the accretion disk. Now, this isn't technically part of the black hole itself. It's this glowing, superheated ring of gas and dust that's spinning around it at nearly the speed of light, getting hotter and brighter the closer it gets.
And next up is the event horizon. I want you to think of this as the ultimate point of no return. Seriously, it's the boundary where gravity becomes so ridiculously powerful that to escape, you would have to travel faster than light. And since nothing in the universe can do that, well, once you cross this line, you are never, ever coming back. And then, at the very center, you have the singularity. This is it. This is where all the mass of that original giant star is crushed into a single point of pretty much infinite density. It's a place where the two pillars of modern physics, Einstein's theory of gravity for the really big stuff and quantum mechanics for the really small stuff, they just collide and break down. We literally don't have the math to describe what's happening in there.
Okay, so let's try to imagine the unimaginable. What would actually happen to you if you fell past that point of no return?
Physicists have this wonderfully descriptive and, let's be honest, absolutely terrifying name for what happens next. It's called spaghettification. It's the process where the intense gravity would stretch you vertically while squeezing you horizontally, literally turning you into a long, thin stream of atoms.
So here's how it would work. As you fall in, let's say feet first, the gravitational pull on your feet would become thousands, maybe millions of times stronger than the pull on your head. This huge difference in force, what scientists call tidal forces, would just stretch your body apart until you were elongated into a thin strand of atoms, like cosmic spaghetti. But somehow it gets even weirder, because gravity actually warps time. So from your perspective, as you're falling in, your watch would tick completely normally. Time feels the same. But to your friends back on Earth watching you through a telescope, oh, they would see something else entirely. They would see you slow down as you got closer to the event horizon. You'd appear to just freeze, turn red, and then slowly fade away, forever stuck right there at the edge. Mind-blowing, right?
Okay, time to tackle another huge myth. People always think of black holes as these cosmic vacuum cleaners, just aggressively sucking up everything in the universe.
That is just not true. Black holes do not suck. Their gravity works just like the gravity of any other object. The only difference is you have to get really, really close for it to become inescapable.
Think about this. If we replaced our sun right now with a black hole of the exact same mass, how many planets would get pulled in? The answer is 0. None of them.
Earth and all the other planets would just keep on orbiting in the exact same path. It would just get very dark and very, very cold.
So if they aren't just cosmic vacuum cleaners, what's their purpose? Well, it turns out they aren't just agents of destruction. They are, in a very real way, the anchors of the entire universe.
So, far from being just these agents of chaos, black holes are fundamental to the way the cosmos is structured. Almost every large galaxy, including our very own Milky Way, has a supermassive black hole right at its heart. Its immense gravity acts as a kind of gravitational anchor, holding the entire galaxy together.
In the end, that's what black holes are, the ultimate mystery. They are these cosmic vaults where the universe hides its deepest secrets, a place where our understanding of reality itself is pushed to its absolute limit.
And that leaves us with this incredible paradox. They consume stars and planets, but they also anchor the very galaxies we live in. Which brings up the ultimate question. Are black holes destroyers? Or are they the creators that make our universe possible in the first place?